So what we're going to do today is, as usual, we do usually we do a quiz review at the beginning of class. Today I want to talk about some commonly missed test problems. Overall, the tests were very nice. I sent out an announcement. The median for this class and the mean were above what the standard was. There was one class that did better. We're number two. So, but you know. There were a couple things that I were very pleased with. The first and the main one was your ability to connect the picture to the arithmetic. Okay, and that, the symbols with the pictures, there was connection going on there, and I was really proud of that. Some of you guys got stuck, especially on that absolute value problem. You drew a picture. You got points for it. It was nice. Some of you, it was apparent that you drew the picture and then figured out the problem. Which was exactly what I was going for. And it's clear that you've made the big conceptual jumps. The big killer was the algebra. And as I said in the announcement, I don't want to go into it too much, but I think that part of that's the onlineness of it, and that it's hard for me to see what's going on if you're having algebra problems. And they are embarrassing when you have them, especially if you're expecting that you should be able to do it. Algebra is not a natural act, okay? So if you're having trouble with the algebra, that's not something to be ashamed of. Now, it is something to be ashamed of if you don't try to fix it now, because, now it's time to fix it. Having algebra problems, that's nothing to be ashamed of. Refusing to fix the problem or talk about the problem that you have algebra problems, that is something, that's a problem. And I know it's embarrassing if you did it. I've done it a couple times where I've been like, I've asked a question in seminar and people are looking at me like, didn't you learn this in grade school? And I'm like, well, stupid, smartest people ask the dumbest questions. That's how we get smart. So don't let the embarrassment, don't let embarrassment be an issue. A lot of people are struggling with the algebra. You're not alone, and it's something that's very hard, and it's not a natural thing. There's a question about whether it's like, I think 3 points lower than it was last semester. And again, a lot of that is that people lost points on algebra, so it's not out of line what it was this time. So it was about 3 points lower, but that wasn't out of line. The average was actually lower than normal. The medians, right, because you've got this large tail of people that are just not doing a good job in the online and the remote, because the remote just doesn't work for them. So people, there's this, it's skewed. There's this fat tail down, right? The median and the mean last semester for my class were pretty much on the money, right, with each other. But right now it's, you've got that same number of people who are doing, well, and then you've got this large tail of people that aren't adapting to the online very well. So part of that's just the fact that we're online. The test itself wasn't out of line. It was a little bit computationally heavy, so it penalized you a lot more on the algebra than like last year's test did. But last year, if you didn't have that picture math concept, it really hammered you. So, it's a mixed bag. Let's talk about some of these commonly missed ones. If there are any other questions I will be happy to talk to you about it. And remember that your lowest test score will get replaced by the final. So if you didn't do well on this one and you do come and fix your algebra mistakes, especially if that's the major issue, then, you can get, you can still go ahead. And, I once had someone tell me that your hardest math course is actually the first one you try to get an A in, right? Because that's the one you're trying to fix all the old problems that you didn't, when you were fine with a C in math and you were like, oh, okay, then you left a lot of holes. So that's the joke, right? The hardest math class you ever take is the first one you try to get an A in, because that's the one you have to fix all the things that you did poorly before, because math is kind of cumulative. It's not kind of cumulative. It is cumulative. So, without further ado, I've already had 5 minutes of ado. Let's go ahead and talk about some of these commonly missed ones. The big one, the first big one. Oh, you guys, gorgeous definitions. And I have a personal thank you from the graders. For some reason, my class seems to have figured out how to put pages in order and scan them and upload them. That was an extreme problem of difficulty for many of the other sections, because we all kind of grade one problem across all the sections. The other sections besides mine, I was sitting there like, what the heck is it? Where the heck is it? Whereas you guys, it was boom, 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 boom. It was very nice. So that was a personal thank you, not only from me, but from the graders. They all commented on it. Well, not all of them, but most of them. All right, so this was the first commonly missed one. Let's talk about it. Lim as t goes to x of 1 over x minus 1 over t over x minus t, or it was the other way. I don't remember which. Okay, so what is this asking for? What is this problem asking for? This problem is saying let f of x equal 1 over x. That nib's bad. And compute f prime of x. So that's what the question's asking for. But it's not giving you this. It's giving you this form. All right, so let's work it out here. And the algebra was the thing that killed everybody on this. So I saw a lot of creative approaches, some of which were actually kind of clever. Wrong, but clever. There are wrong but clever answers, by the way. So what I'm going to do here is I'm going to take a common denominator on the top. Now, there are a couple ways of viewing this, but 1 over x minus 1 over t, all over x minus t. What I'm going to do is sort of like the thing, you know how, this is kind of an aside. If I have a over b, that's really the same thing as a over 1 times 1 over b, which is the same thing as a times 1 over b. Okay? So a lot of you flipped this thing when you did it, right? You moved the x minus t up to the top, and that's not where it goes. Okay? So let's do this first. Let's undo this. So I've got this limit, and I can't use the rule yet, but I can do something like this. 1 over x minus 1 over t, all grouped together, times the quantity 1 over x minus t. This right here, if I did this first, I got rid of the kind of ugliness thing that becomes kind of weird. Now, that's one strategy. I mean, you could do this problem fine, leaving it on the top if you so decide, leaving it in this form like you desired. But that's one way to kind of get rid of this ugliness. Okay. Now, I need to take a common denominator here. Okay. Because I can't really, I can multiply this across, but I'm going to wind up with two terms, and that really doesn't help. Okay. Because I'll have a 0 under both of them. So let's take a common denominator here. What I'm going to do is I'm going to do 1 over, so I'm going to do t over xt minus x over xt. So I just multiplied this term here by t over t and this term here by x over x. And I wind up with this. Okay. And then what I do here And you may be tempted to sub in right now, but the problem is that this thing's limit is infinity. And if you sub in here, you're going to wind up with 0. And you'll wind up with a 0 over 0 times infinity. And that doesn't really help. All right, so what I'm going to want, that's like doing 0 over 0, right? 0 times infinity is the same thing as kind of 0 over 0. It doesn't really help. All right, so what I'm going to do now is I'm going to have t minus x over xt, because I took a common denominator, times 1 over x minus t. Okay, now this term here and this term here look a lot alike. In fact, if I multiply through by -1 here, or here, I would get the same term. Let's do that. What I'm going to do is I'm going to factor out -1 on the top here. So what I get is negative t plus x over xt times 1 over x minus t. And this right here is the same thing as x minus t. And now I have two terms that will cancel. Now I need to sub in x for t. Okay. So there were two algebra tricks that were really important here. Actually, there were three. Okay, so common denominator. Okay, there were three. This was an involved problem with three different kind of algebra tricks. Okay. Yes, this is on Twitch. As usual, you could talk here or in Twitch. Did I not put the stream information? I didn't, did I? There's the stream. Okay. So how do we feel about that problem 1 to 5? There's a lot there. I'm starting one. I'm starting one. There we go. It takes a moment to start up the poll, right? As I said, that problem was mean. It has a lot of algebra in it. It's actually kind of an important one, though. There's another way to do that problem. You could have said, oh, that's the definition of the derivative, and then dealt with its other one. Whether or not that's easier or not is another question. If we did lim as h goes to 0 of f of x plus h minus f of x all over h, you could have said that's the definition of the derivative and then changed the problem, which is, it's kind of a cheap way of doing it, but it's a nice way of, actually it's not that cheap of a way of doing it. It's a very nice way to do this problem. And then what you do is you'd say, okay, well that means that this here equals 1 over x plus h with the limit sign. Limit as h goes to 0. 1 over x plus h minus 1 over x all over h. And the advantage of this is that the bottom becomes easier. And then what I do is I do the same kind of thing. I take a common denominator. I'm going to do 2 steps at once. What I'm going to do is I'm going to take the common denominator and change it to the multiplication problem. So this is going to become x over x plus h with an x multiplied minus x plus h over x plus h x multiplied times 1 over h. Again, I'm doing multiple steps at once here because I already did the kind of thing above. So if you don't like it, that's okay. I mean, it's not okay. But one of the nice things about this is if you do it this way, once you take the common multiple, those x's go away. So you have on the bottom here h times x times x plus h. And now those x's cancel on the top, and it makes the problem a little bit easier. I mean, it's obvious what's about to happen now. 1 over x times x plus h equals ds. There's no limit there. 1 over x plus x times x plus 0 equals 1 over x squared. So the problem's a little cleaner if you use the h definition. Are there any questions about that? Yeah, so as I said, this right here had a bunch of algebra tricks. Okay. All right. The other big one that was missed was this kind of 1 over... The other one that was missed was, use the definition of the derivative to prove... use the definition of the derivative using the definition of the derivative. Prove d over dx of what was the function? It was like 1 over the square root of 4x plus 6 or something like that. Yes, you're right. I screwed it up. Thank you. Yes, this should be... I didn't distribute my negative. Idiot. Stupid. 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 Okay. Me, not you. Sorry about that. What was the exact wording of the question? Thank you. I'm sorry, I screwed that up. You couldn't have spent 20 minutes staring at it. The exact wording of the question was... oh, 2x, it was 2x plus 5 equals 1 over the square root of 2x plus 5. And this one looks easier than it actually is, because there's a red herring in here, which is the 2. Right. I'm sorry, it was the square root. That would have been wrong. It was this. The square root of 2x plus 5 equals that. Okay, so let's see, how do we do this? I had to look it up. There we go. This is the one I want. I want the one where it shows me the questions. Yeah. Okay, now it's correct. I looked it up. Okay, and this makes me feel silly. And I did it all over Twitch, and then it's going to be on YouTube, right? I forgot to distribute my -1. Okay, so what I'm going to do here, right? I need to use the limit definition, right? So what I'm going to do is I'm going to make it work a little bit better. I'm going to say let f of x equal the square root of 2x plus 5. And I want to show that f prime of x equals 1 over square root of 2x plus 5. My strategy is definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay. So the trick here is what this becomes here. All right. So I'm actually going to write it down right now. F prime of x, I'm sorry, not f prime of x, f of x plus h equals. Now, I'm going to write it down. I've got f of x is this, so I'm going to write equals the square root of 2, and now I'm going to make the sub in x plus h plus 5. So that's a tricky part. Not doing that subbing correctly is a little bit tricky. Okay. So I'm going to do that separately. All right. And then what I'm going to do is this. Okay. F prime of x, therefore, equals the limit as h goes to 0 of f of x plus h minus f of x all over h equals. Now I'm going to plug in this one and this one. By the way, bringing a highlighter to a test actually is a good idea. Because it lets you keep track of these things. You know, the important thing is what f is, not what f prime is right here. Okay, so the limit as h goes to 0 of the square root of 2 times x plus h plus 5 minus the square root of 2x plus 5 all over h. Now I multiply by the conjugate. Okay. So now I'm going to get rid of the thing on the top. This right here becomes a nice little difference of squares in a sense. It's going to become 2x plus h plus 5 minus 2x minus 5. Oh, look at that. The 5s are gone. That's convenient. The x's are going to cancel, and all I'm going to be left with is a 2h. H. Now, do not distribute this h. Okay. I'm going to distribute this. The limit as h goes to 0. Let's get rid of these 5s. Two x plus 2h minus 2x all over h times the square root of 2x plus h plus 5 plus the square root of 2x plus 5. Now the x's are going to go away. And I am left with the limit as h goes to 0 of 2h over h times the square root of 2 times x plus h plus 5 plus the square root of 2x plus 5. It's obviously getting right heavy here, isn't it? These h's cancel, and I am left with I'll run it off here. And I am left with in blood. And I am left with the limit as h goes to 0 of 2 over square root of 2x plus h plus 5 plus square root of 2x plus 5. And there's a lot of opportunity for messing up a carry here. Now I directly substitute, and I wind up with 2 over the square root of 2 times x plus 0 plus 5 plus the square root of 2x plus 5, which equals, that of course becomes 2 over 2 times, let me actually write out why it's a 2. To the square root of 2x plus 5, because that became 0, plus the square root of 2x plus 5. Now that becomes 2 times the quantity 2x plus 5. 2 over 2 times 2x plus 5, and the 2's cancel. And I wind up with 1 over the square root of 2 plus 5, which is what I wanted. Make this a little neater. Okay. That one is just long, and I think this thing just took forever, and it was just long, and it wasn't so much that there were a bunch of algebra tricks. The only big trick was the fact that you had to do the conjugate, but it was just like long. So how do we feel about that problem now? It was just took forever. So the H problem. So there's a question, do we get to see what's wrong? Do we get to see our markups and everything? There's not a lot of markup. You will get to see the test. You will get to see everything about it. If you want to dispute a problem, if you want to dispute your partial credit, you will be able to. But it can't happen until Tuesday late or Wednesday morning because that's just what we all agreed to. And the big tricky part of this problem is its length. The other tricky part of this problem is if you tried to use the XT definition, you would have gotten it would have been unpleasant to say the extreme. You could have done it because you just multiply by the conjugate and then let it go to h, and it does work out. But it can get you can mess it up. Okay. Are there any other questions about the test? I mean, it's. I don't want to spend too much time on it. No, you don't have to. You don't have to multiply by the conjugate every time you have a radical. You multiply by the conjugate when you have a radical you can't deal with. So it's a good trick, and the reason why they keep doing these is because if you go on in math and you start dealing with complex numbers, multiplying by the conjugate is just the way you deal with, well, everything. When it comes to doing stuff on the complex plane, especially if you're going into like electrical engineering or math itself, but even in math, I didn't really encounter complex numbers until I got to graduate school, but electrical engineering deals with them all the time. So that's why they keep putting these in. As I said, this class shares a lot of things. You guys did awesome on the graphing problem. The hard problem you guys actually did pretty well on. Those of you got that stuck, drew a picture, and that actually saved you here. The one, that was pretty much it. Those were the only ones. You guys did awesome on the sine problem. I really, the sine u over u problem, I really like the fact that you guys subbed in for u a lot. Some of the other sections didn't. A lot of them got stuck on that problem. And you guys did it. You guys did a great job. The way you wrote things was very clear. Your part B, your nothing else matters were very pretty.